I suppose that we can go. So that's people in Chapman normally come at the time, but then they continue to speak. There's no way to make them stop to speak. They speak and speak and speak. Overall, when they come from Mexico, there is no way to make them stop to speak. Mexico and Brazil, that's terrible. That's terrible. Okay, so I think that we can begin now. That's a great pleasure to have Robert May with us. So I think that not all of you know Robert personally, but certainly all of you know Robert for the work that he did in philosophy of mathematics, philosophy of logic, linguistics, and many other things. Also for his very important administrative role in the University of California. So that's a real pleasure to have such a leader scholar at the Chapman and such a good friend. So the title of the talk is Definition and Content in Frege's Logic. So I think that I have only to ask Robert to begin. I think that the format is the usual one. Unless Robert is against this practice, if there are some explanation questions on local point during the talk, you can ask for explanation, and if not, there will be a discussion on that. Okay, thank you, Robert.
Thank you, Marco, and thank you for having me. It's a pleasure to be here. Let me just get here. So this talk is sort of a part of a long, now getting rather involved in long arc of thinking about definitions in Frege. It started with just sort of an odd observation when I was working on the translation of Grundgesetze. I was looking through the table of contents and noticed that the proof of so-called proof of referentiality, which we'll discuss later in the talk, to show that the Begriffsschrift, the logical language, was a consistent language, was plunk in the middle of Frege's basic discussion, setting out his canons of definition, which would lead one, and you just sort of see this in the table of contents of the book. And so it got me, why did he think of this as sort of essential to the characterization of definitions and how that would play a very fundamental role? So I got thinking of this, and particularly reflecting on the work that Rachel Boddy did in her dissertation, which was really working and thinking about the things she was telling me about, got me thinking about this. So one of the things that I don't know if it's an epiphany, but one of the things that affected me was that it really made me try to articulate what I really thought Frege was out about doing. What was his main kind of goal in the way he was talking about things? What was he trying to do? And to put it very, oops, okay, all right, Marco. Oh, I didn't start the recording. Did you?
No, you did.
I did start the recording? Okay, so just let me.
No, I started recording.
But I'm not getting the.
Oh, why not?
Oh, okay, that's good. Which button did you use? That one. Okay. So in kind of setting up sort of the where I kind of ended up on sort of thinking in general about Frege.
Go. I want to see whether it is recorded. Go.
Okay. About Frege. I kind of sort of, you can sort of think about Frege's scholarship, when it fits in Frege's scholarship with I want to put a very broad brush on sort of the strains of Frege's scholarship. There's two, which are kind of, I think, fairly obvious, two trains of thought. One which takes what Frege was really concerned with, an epistemic project, and fundamentally. And for those who are concerned with this, in general, the notion of sense is really the primary notion. And what they're concerned with is what grounds are being given to the assertion of thoughts. And for these folks, Grundlagen and the essays are key documents. Right? This is very broad brush. You can put in whom you like, the sort of hagiography of Frege scholarship into these categories as you like. The second is metaphysical, and here really reference is the key notion. And what's the concern is by the grounds of the assertion of truths, and the Grundgesetze is generally the key document, okay? And depending on where you're coming from, you have a very different take on a lot of things in Frege. So for example, propositional composition is what's key is the composition of senses and the thoughts, okay? Or is it about the composition of concepts and objects into truths? So where's the action there? And of course that relates on how you think of the concept-object distinction. Very different takes on abstractive, okay? What are the main notions? I mean, if you're an epistemic, you're concerned with sense and how is sense going to give you epistemic foundation, such as something you can refer to. As opposed to those metaphysical tend to be concerned with things about what's the nature of value ranges that we're going to talk a lot about and numbers in general, okay? And this comes down to a very different take on what logicism is supposed to be in Frege's hands. This is supposed to be something which is asking after the question, what are numbers? Which would be someone taken to the metaphysical point of view. And the other is what is to have knowledge of numbers, which would be the more primary notion, which those concerned with the epistemic perspective. So I'm going to offer, at least in my mind, as I sort of broad brush this out, a kind of third stream. And that third stream is that Frege's main project is the construction of a scientific theory. And that the fundamental notions that he brings forward, including the notions of reference, sense, and reference themselves, are first and foremost theoretical notions in the context of the theory. And that epistemic and metaphysical questions are about these theoretical notions. So the questions, the epistemic and metaphysical questions would be reduced to general epistemic and metaphysical questions about the nature of scientific theories, how we understand the scientific theory about something which seems to have cognitive significance as well as objectual significance. Okay. All right. So
No. You have simply a question to come back to. I don't know what is that. Okay.
All right, we're better. Okay. So Frege's project is theory construction on the way I'm looking at things in general and specifically. So much of what he's writing about is to determine the characteristics of a proper scientific theory. How do you put such together? What would the language in such a theory be like, and so on. And secondly, to build a theory with these characteristics. And in particular, the theory that he's going to be interested in is arithmetic. So if you're concerned with theory construction, right, what's the first thing you're going to do if you're going to put together a theory is you have to figure out what are the fundamental concepts you're trying to express in that theory. What are the fundamental concepts, okay? So what is the theory? What are the concepts in which it's constructed? And if you're going to ask that question at the general level, you want to ask, what are the theoretical resources required for expressing those concepts? What does your underlying language, your underlying theory need to look like such that you can express the basic concepts which the theory you're constructing is about? And this is where definitions come in. So definitions are going to be those statements which characterize the fundamental concepts of a theory, okay? So part of what you're doing in theory construction is, one, giving general conditions on proper definition as part of the characterizing a proper scientific theory, and secondly, giving specific definitions of theoretical concepts in the theory that you're constructing. And of course, this one will be, in the case we're considering, definitions pertaining to number. So the talk I want to talk about, I wanted to look at a paper, actually an article that Frege wrote in 1914 called Logic and Mathematics. We have, thanks to Eric, we have access to Carnap's notes about the class that Frege wrote when he was writing this essay, which is a great companion piece to understanding much of what he does. And this is really, I think, when you read this, you really understand, this is 1914, so this is before Frege has sort of this late bunch of essays that he writes. But he's really looking back at sort of the way he put things together, the way he saw things. It's very reflective, I think. And he makes some very interesting and weird, one might think in certain contexts, remarks. And these three remarks I just want to read out because these are the ones I really want to discuss in the talk. If it is our intention to put forward a definition proper, we are not entitled to choose a sign A, which already has a sense, but we must choose a fresh sign B, say, which has the sense of the complex expression only in virtue of the definition. A sign which hitherto had no sense acquires the sense of a complex expression by definition. Goes on. If we have managed in this way to construct a system for mathematics without any need for sign A, we can leave the matter there. There is no need at all to answer the question concerning the sense in which, whatever it may be, this sign had been used earlier. Forget about it. Okay. And then he says, we must therefore explain that the sense in which this sign was used before the new system was constructed, is no longer of any concern to us, that its sense is to be understood purely from the what we'll call an analytic definition that we have given. In constructing the new system, we can take no account, logically speaking, of anything in mathematics that existed prior to the new system. Everything has to be made anew from the ground up. So this seems to be a sort of manifesto for the theory construction. We're going to construct a theory of mathematics, a mathematical theory, okay? And we're not going to be, in some sense, as I'll elucidate in a moment, we're not trying to sort of reconstruct something out there. We're trying to give a completely new construction, a theoretical construction in mathematics. Okay, so on the view, arithmetic is built within logic. From the analysis specified the definition by, quote, constructing a new system for mathematics from the bottom up. And what it has to do, what this pertains to definitions, it means that the definiendum of a definition is not a term imbued with a sense in prior use to be revealed by the analysis by the definiends. Rather, the analysis of the definiends is bequeathed upon the definiendum as an empty shell. So, Frege's business is theory construction. Definitions are the foundation of the construction. Definition of number in this case is a theoretical analysis of the concept of number. And the justification of the definition resides within the context of the justification of the overall theory. So note that, however, just to be clear, theoretical analysis in this sense is not a reconstruction of the concept of number pre-existing in conventionalized mathematical practice. The goal is not to give an explication of terms in use in that practice, as we just said. But to be clear, I don't think Frege is denying that the theory serves to explain, that it does not deny that the theory serves to explain conventionalized mathematical practice. To the contrary, in virtue that the theory reveals commitments and consequences of the practice in the sense of a scientific explanation. So all he's denying is that the form of explanation depends on definitions bridging notions in use in the practice as definiendum to analytic theoretical notions as definiends. So he's not, so to speak, giving a direct analysis of what we learned in arithmetic in school, just as, for example, we wouldn't expect our theory of language, our linguistic theory, to be an analysis of what we learned in grammar. It's pretty much comparable cases. Okay. So two things I'm going to want to discuss in the course of the talk. And the first will center around sort of how this all resides with Frege's logicism, okay? Well, the notion of logicism is to develop arithmetic and logic as the first science, or as Frege says, and we'll discuss later, to show a unification of arithmetic and logic. And Grundgesetze, of course, was to be the culmination of this project. And he says there, I here carry out a project that I already had in mind at the time of my Betriebsschrift of the year 1879, and which I announced in my Grundlagen der Arithmetik of the year 1884. By this act, I aim to confirm the conception of cardinal number, which I set forth in the latter book. Okay, so what's the conception of cardinal number? Okay, well, it's the conception is captured by the definition of cardinal number of a concept. It's a central core notion. He initially does this in Grundlagen, formalized in Grundgesetze. We'll talk about that more. And what it does is it defines the number of a concept as its cardinal equivalence class. And this is the central notion on which the theory is going to be constructed. Okay, it's going to be a fundamentally logical definition. Okay, so the idea is that the fundamental notion of which is the fundamental arithmetic notion is one which will be characterized by a logical definition. And I've given you for the beginning, the Grundlagen definition, the number of f, concept f is defined as the extension of the concept being equinumerous with f. Now, the other part of talk I want to talk about are two theses in Frege that are really, he cannot, neither of which he can really give up, or he has to give up one of them actually, because they conflict. The one is the following. I've been talking as I've been going along that what's at the foundation of a construction, theoretical construction, is the characterization of the fundamental concepts, and that we want to give definitions of those concepts, okay? So what definitions do, and Frege clearly holds this in a very traditional way, that the role of definitions is to characterize and define concepts. However, for Frege, the way he gives form of definitions, as we'll see in a moment, are as of objectual identities, okay? But problem for Frege is that he's trying to give a definition, which is an identity, but it's supposed to be about defining a concept, but conceptual identities are inexpressible in his logical language, okay? Because identity is objectual. It holds between objects, not between concepts, okay? And this is essential for Frege because of one of the key moves he makes to make a reductionist program is to analyze arithmetical equality as objectual identity. That's one of the key moves that he makes. And it's a move he has to make if he's going to really carry forward the logicist project as a reductionist project. So in this regard, concepts appear to be indefinable in Frege's system, okay? And what he's going to do to deal with this problem is he's going to give objects, he's going to posit objects that represent concepts, and one of their main goal utilizations is to be allowed for the definitions. So these are going to be the value ranges, or the case of concepts, they're extensions. And as we'll see, the problem, of course, is that this leads him directly to Russell's paradox. Okay, so that's the intro. So let's move on. Okay, so just a little bit of background for those of you who are, somewhat unfamiliar with how Frege writes definitions. He gives the form as I've given there, okay? Definitions are identities marked by the double stroke of definitions. And Frege, unlike what we do today, gives the definiens first and the definiendum second. So the definiens always occurs on the left-hand side of the identity, the definiendum on the right-hand side, okay? And here's what he says. This is in Grundgesetze. By means of a definition, we introduce a new name by determining that it is to have the same sense and the same reference as a name composed of already known signs. The new sign thereby becomes co-referential with the explaining sign. The definition thus immediately turns into a proposition. So on Frege's view, the definiens and definiendum are co-referential proper names. Now, definitions in Frege are, in a sense, linguistically innovative. They do create new terms. They introduce new terms into the language, but they are semantically conservative. So by definition on Frege's canons, we cannot add to what is otherwise expressible in the language by the definiens. So definitions in this sense are abbreviatory conveniences. Quote, they serve to call special attention to a particular combination of symbols from the abundance of the possible ones, and thereby obtain a firmer grasp of it for the imagination. Definitions make something prominent by demarcation and then designate it with a name. Now I'll come back to this remark because notice it sort of plays two things. On the one hand, it's sort of a cognitive flavor to this comment. It makes something prominent and gives a cognitive feel to it, but then it's designated with a name, which gives something which is formal and linguistic, and I'll come back to that. There are two types of definitions that Frege gives in his definitions, and we can distinguish them between generic definitions, which introduce function names, and definite definitions, which introduce proper names. Come back to that a little bit too. So now I want to give a couple more kind of focusing quotes. First one from Grundlagen, and the second one from On Sense and Reference, because I think these really connect in an important way. So the first one from Grundlagen. Yet it must still be borne in mind that the rigor of the proof remains an illusion, even though no link be missing in the chain of our deductions, so long as the definitions are justified only as an afterthought, or are failing to come across any contradiction. For this reason, I have felt bound to go back rather further into the general logical foundations of our science than perhaps most mathematicians will consider necessary. Then in On Sense and Reference, a logically perfect language, Begriffsschrift, should satisfy the conditions that every expression grammatically well constructed as a proper name out of signs already introduced shall in fact designate an object, that no new sign shall be introduced as a proper name without being secured a reference. This is actually just an instance of what Frege holds more generally. It's not just proper names, but also function names. So definitions, and here's where these things are going to come together. Definitions are justified if they are used in proofs carried out in a logically perfect language. So it's the logically perfect language that's going to give the milieu for the proper formulation of definitions. And how does Frege establish that we have a logically perfect language? And this is where the proof of referentiality comes in, which is found in Grundgesetze sections 29 to 32. And as I said before, it's plunk in the middle of general remarks on definition, which spans from sections 26 to 33. And in this, by the proof, Frege sets out to show, and believes he's shown, the logical language is a referential language. And in this sense, it's logically perfect. He gives inductive demonstration that the language contains only correctly formed names, which are either referential names and function names. The metalogical content of the proof is well known. It would constitute a consistency proof and would show that the language is sufficient for characterizing proof as rigorous, gap-free formal derivation. So it's the proof of referentiality that provides antecedent justification for definitions. It guarantees that definitions introduce referential terms into the language, into a referential language. And so if the definiens is referential, then so too is the definiendum. Okay? So we have now the prior justification that we could not be introducing any inconsistency into the language, which is what he asked for, okay, because the language itself is provably a consistent language. So if we have the definitions conservatively over that language, we are guaranteed, we have justified appropriately our definitions, okay? So a definition is justified if and only if it's composed of terms of the logical language aside from the defined terms. So now let's look at the key definition. So this is the definition from Grundgesetze of the Frege. Yes.
That's like the last thing on the previous slide.
Yes.
But does that mean that recursive definitions are not allowed?
Frege does not have any recursive definition.
Okay.
He only has purely explicit definition. He only has definition of the form which I picked. Okay.
But some of them are definition of concepts.
But some of them are definitions of concepts, exactly. And how he makes them definitions of concepts is what I'm going to talk about.
The question that by definition we cannot introduce new contradictions doesn't mean that the language itself from the beginning could have contradictions.
And it does.
But we cannot
but it's closely related to the introduction definitions. That's what I'm leading to in the talk. To show how what he has to do to get the language set up to introduce definitions is going to open the door to the consistency. You're right. That's where we're headed. Okay. Okay, we're good. Everybody good? Good. Okay, great. Okay, so let's talk about Frege. I'm going to give the definition in Frege's notation. This is the key central definition. This is the definition of the cardinal number of a concept. Okay, and we can roughly paraphrase it by saying for any value range U, the symbol, I don't know what to call it. I never know what to call that symbol, so I'll call it number U. Stands for the value range of the concept being equinumerous with U. Okay, and this value range is the cardinal number of U. So, well, the story is. Yeah, no, that's what people say, that because it was such a problem. He basically said, "Here's the box, pick out something from it." But then somebody else said, "No, it's actually it's some kind of, I don't know." That's a dinner time conversation. Okay. So definition zeta introduces a function name. What it introduces is a function name into the language. So the name that introduces into the language is the squiggly symbol, which is a function term, which the meaning is going to be patched out by it referring, that term will refer to a function that returns for each value range its number. Okay, so the first question we need to ask, is definition zeta a logical definition? And the answer is it will be, just in case the sign is composed of signs that are primitive or introduced by definition. Okay, and in fact, it does. You just have to unpack it. It turns out, just for those who are interested, it turns on the following definitions: the definition of membership, which we're going to come back to, single valuedness of a relation, mapping into by a relation, and the converse of a relation. Okay, so basically, it gives you a bijective relationship. Okay, and it turns out that each of these definitions is stated in primitive terms of the Begriffsschrift. So Frege introduces definition zeta as the definition of the cardinal number of a concept. Okay, it's the cardinal number of a concept. What he does not give us is a definition of number simplicator. He does not give us a definition of cardinal number simplicator, only a definition of the cardinal number of a concept. Okay, and that notion, the notion of cardinal number itself, receives no definition in Grundgesetze, and is in fact not needed for any of the proofs in Grundgesetze. So they would be in a completely otiose definition and hence not a usable definition. Nevertheless, Frege points out in Grundgesetze that the concept of number can be characterized. So what we have here, which is there is a number of there is the number of, well,
I'm sorry. There is no definition of the number simplicity
of notion cardinal number simplicity.
But there is a definition of natural number.
There is a definition of natural number, but that is built on the definition of cardinal number of a concept.
The natural number is defined.
Yes. Yeah. So what we have there, so the line, concavity, etc., that's the existential quantifier in Frege. So you can say there's a value range U, such as the number of U is gamma, is the truth value of that there is a concept of which the cardinal number gamma belongs, whereas we also say that gamma is a cardinal number. Therefore, we call the function, there is a U, number of U equal gap, the concept cardinal number. So the concept cardinal number is simply the closure over all the cardinal numbers of a concept. So what falls under the number are just the cardinal numbers. And the value ranges are identified as numbers of concepts by definition zeta is what falls under that concept. And notice in this line of thinking, definition zeta has a conceptually prior position. How am I doing on time? I think I might go, just go. Okay. So I just wondering if I should, okay.
Because we want to give two talks.
Oh, right, I gotta go quickly through this one so I can give the second talk. So there's another talk I want to give too. So if you want to hang around, I'll give a second talk. Okay, so this priority of definition zeta reflects a remark in Grundlagen. Okay, actually, no, I'm going to skip this. We can come back to it. This is about, I'm going to skip, this is about Hume's principle. I'm going to skip Hume's principle. Okay, so the last thing I want to say, if anybody's interested in the question and answer, let's say go back to the slides on Hume's principle. I'll go through Hume's principle. So definition zeta by Frege's lights is a prototypically what he would call a fruitful definition. And fruitful definition has been a lot of discussion what Frege means about this, but the way we're thinking about it is that you can look at definitions from two different ways from Frege. One is this is from Rachel's work, what she called analytic definitions. And these are definitions which are intended to be explanatory of scientific concepts, where the analysis is carried out by the definiens. And what's remarked about this is that when you're positing a definition in this way, it's going to be open to critical investigation and philosophical argument. So much of what Frege spends time on in Grundlagen is showing and arguing that other attempts to define appropriate numerical notions are in some way defective. Right? They have some defect to them that make them, fingers and toes, pebbles, aggregates, various things he looks at. These are all ones which are not going to be proper, and he gives critical arguments about that, okay? Proper definitions, however, just has to do with usability and formal derivations.
But it's not in contradiction with what you said in the beginning of the presentation, like you are to describe the sense from scratch.
Mm-hmm.
So how can you criticize that definition on the fact that there are not two definitions if any definition construct the sense from scratch?
Well, they wouldn't be.
How the two positions stand?
I mean, they wouldn't be definitions because remember, ultimately the justification comes in the context, the role it plays in the entire theory, which is, so if it can't play the proper role to define what you want to characterize in theory, for example, the concept being a natural number, then that would be a very good argument that it's not a good definition. But it could be properly formulable within the language. Right. So remember, proper definition, if it's formulated in, there's no way for a proper definition considered as a proper definition to be defective. It can't be wrong. If it's simply stated in the language, it has to be good. Any concept expressible in the language, any term expressible in the language can be replaced by another term under definition. Absolutely any expression whatsoever in Frege's world.
Yes, my point is that the notion is the term number has no sense before the definition, is acquired sense of the definition.
Correct.
How can you say that the definition given by Dedekind is not correct?
Okay.
Without comparing the sense that the Dedekind gives
But
the
look,
number with the sense that the term number should have.
Sure. But I think Frege's response in general would be, okay, and I mean, Eric will be the one to tell us about this, but I would say that in a certain sense, the response is, okay, you have another theory of this, okay? And now we can compare our theories, just like you would any, if you have something and you have two theories which are overlapping in what they're saying, then you have to sort of consider, well, why, what are the underlying principles? What's the nature of the theory? Is one preferable? Is one just, are you just left in the sort of incommensurability world where you just have two accounts and there's just sort of no way to pick between them? There's all sorts of things that happen in everyday science. And I think that would be the response, that this is just, there's other ways, and then you have to just sort of look at different theories. But I'm sorry, just want to say, but what I would deny is that I don't think it would be a good answer, and I don't think Frege would make this answer, to say, my theory is right because it picks out these objects as sort of as a metaphysical claim. I don't think he'd make that argument. That somehow my objects are the right objects and your objects are the wrong objects. Yeah, it's not exactly right. That's exactly the point.
And I think that Eric also.
Yeah, yeah. In fact,
I think that
a lot of what Eric said about this is what. Well, I think a lot of what Eric said about.
To find the
Yeah.
that agree on that.
Yeah.
Not
Yeah.
easy.
In fact, a lot of what Eric has said about this was very influential in my thinking about this. So, yeah.
But isn't it important that we're using the word good in the expression good definitions with two different senses? One is this a correct definition, the other is it's an appropriate definition.
Yeah, I mean, it's just two things. And one is what concept is it capturing on the one hand, and you can sort of look at that. And the other is, well, given that it captures the right concept, I mean, is it going to actually allow you in the context of theory to actually prove things about them? Okay. And so now I'm not saying there are two kinds of theory, two kinds of definitions. This is the definition. But we can ask about that definition. Is it actually explicatory and explanatory of the concept? But to do that, it has to also be able to be part of the way we're going to characterize, prove the properties of the concept.
Can you give us examples that I can that would help me to understand the difference between a analytic definition and proper definition?
There is no difference between them. The definition is just the definition. There is just the definition, okay? But
Well, you can finish that.
But what Frege does in Grundlagen, for example, he is there to attempting to justify the definition as a proper noun. He has a section, he said the definition completed and its worth shown, okay? Why is this a good definition? Why is it worth, right? Okay. In Grundgesetze, he assumes the definition, he gives a form, he formalizes the definition, and then he shows how it's going to work in this construction of which leads to the derivation of the basic laws of arithmetic. So there's just one definition. Yeah.
I'm still trying to wrap my head around the definition of proper definitions and the bullet point. So can you give an example of a proper definition that is accepted?
No. No, you can't, because the only way proper definition in this regard would be, that's the point, you can't. As long as it's formulated in the language, because it's a well-formed formula of the language, it will have to be completely proper definition.
But
I guarantee you.
you're saying if a proper definition is effective, then there's some mistake.
Yeah, if you screwed something up, you know, it's like, you know,
It's
so
not
your
it's not
computer,
proper
you're
definition.
doing,
It was never a proper definition.
there's no proper definition to start with. Right?
Okay, so if a definition is defective,
If you fucked up,
uh,
what can I tell you? Right?
yeah, what is the characterization of defective? What,
Well, I mean, earlier. You said that it was just, you can't use any symbols.
Yeah, I mean, it would be defective if you formulated it using terms that were not already characterized in line.
So you can just imagine something like that.
Yeah.
Make something like
Yeah,
that.
I mean, I mean, the point is, I guess I didn't state this well, but what I meant to say was you can ask about a definition, whether it's right or wrong, or, you know, appropriate or proper in characterizing a concept. And we can sort of look at that and, you know, that's what we do as philosophers. We try to figure out that. Okay, whether the definition has a fact, what's capturing. That's one activity, and there's something you can say, well, yeah, it does or it doesn't. But if the definition you're giving is properly formed in the language, there's just no thing about being defective or non-defective. It's just sort of not a category mistake. Okay, it's just what it is. Okay, so if it didn't, you know, if it didn't work, it's as if you wrote a line of code in a computer program, and you know you made a left bracket rather than a right bracket by in your list of key. It's kind of like that. Okay, be defective like that. Okay.
so if I think of it from a computer science perspective, a proper definition would be something that's compiled.
Yeah.
Okay.
Okay. Okay, I think we got all this. Let's move on. Okay, so there's something which I think kind of has always, you know, been on the minds and bugged people who've worked on definitions in Frege. It's this problem. So the definition is constructed in the Begriffsschrift is semantically conservative over the language. Okay, so you can't create terms for content to which reference could not otherwise be made. So how is definition to be justified not only as a logical definition, which we do because we saw that it's constructed in completely in the logical vocabulary, language of the Begriffsschrift, but also a mathematical definition. Remember, it's supposed to be the definition of the cardinal number of a concept. It's supposed to be the foundational notion for the construction of arithmetic, this new reconstruction, okay? So it must be the case that in language, we assume, since this is supposed to be a construction of arithmetic, that there are terms for numbers which are recognizable as occurring in the logical language, okay? Because otherwise, you know, logicism would fail as a reductionist program. We have to be able to recognize that these logical propositions have mathematical content. So Frege's answer is that definition zeta reveals mathematical content manifest in logic itself. And in that regard, the definiens refers to numbers. And I think the main evidence for this comes from his discussion in the paper on formal theories of arithmetic, which was published in 1885, shortly after the publication of Grundlagen, okay? And there he lays out that logic and arithmetic are not to be differentiated. And he says, no sharp boundary can be drawn between logic and arithmetic. Considered from a scientific point of view, both together constitute a unified science, okay? And the terms of a definition are traced back to the primitive notions. He says these ultimate building blocks of a discipline contain, as it were, in a nutshell, its whole contents. Notice this building metaphor comes in as early as 1985. This construction type of metaphor comes in. So the building blocks of arithmetic are logical. Therefore, if arithmetic is to be independent of all particular properties of things, this must also hold true of its building blocks. They must be of a purely logical nature. From this, there follows the requirement that everything arithmetical be reducible to logic by means of definitions. Okay? And finally, arithmetic and logic as a unified science have the same foundations. The boundaries of a discipline are determined by the nature of its ultimate building blocks. So the idea is that what we're constructing from has arithmetic content. So it has to be that the whole contents of arithmetic are contained in the logical building blocks. And definition zeta roots us back to those foundations, to the arithmetic content of logic. Definiens expressing a logical concept also expresses a recognizably mathematical concept. So in this regard, one-to-one correspondence is to be identified with equinumerosity. That is, what equinumerosity means is explained as a one-to-one correspondence, as Frege says in Grundlagen. The expression, the concept F is equinumerous with the concept G, is to mean the same as the expression. There is a relation phi which correlates one-to-one the objects falling under F, the concept F, with the objects falling under the concept G. So the logical term, one-to-one correspondence, and the mathematical term, equinumerosity, are co-referential, and arguably, we could say they're even synonyms. Okay, so where am I up to? No, that's covering over. I think this is a new section. All right, so let's go back now to sort of the final discussion to the Grundlagen definition. Number of F is defined as the extension of the concept being equinumerous with F. And Frege makes a very enigmatic comment, which people have really kind of gotten their minds boggled about. He says, I believe that for extension of the concept, that term, we could simply write concept, okay? And it seems that there's really only one way to make sense of this, which is to hold at this, what Frege entertaining this, he's entertaining that concepts are simply extensional. And he's identified the concepts with the classes that they are extensions. And if so, it would follow that there's no change of meaning for substituting extension of the concept for concept. So he then lays this out, and then he says there may be two objections to this. The first objection is it contradicts that the individual numbers are objects. And secondly, the concepts can have identical extensions without themselves coinciding. So let's look at the first objection. Presumably, it's something like this. If extensions are identical to concepts, it follows that extensions are not objects. But hence, numbers are not objects, given that they're defined as extensions. So that's where the contradiction comes in. So to get around this, Frege has to give up one of two assumptions. He has to either give up the distinctness of concepts and objects, or that extensions are identical to concepts. He's got to give up one of those, okay? Well, he can't give up the first. He's deeply committed to the first. He maintains in Grundlagen, as he says, never admonishes us, never to lose sight of the distinction between concept and object. And on concept and object, the essay is much taken up with basically showing us the horrors of not respecting that. So Frege must reject the second assumption. Extensions are not identical to concepts, okay? And if they're not concepts, then extensions are objects. And this is a part of what he argues for on concept and object. Now, so if we're going to take it, now Frege's going to take that concepts and extensions are distinct. And this claim has semantic repercussions. And he points this out in this very well-known comment on concept and object. In logical discussions, one quite often needs to assert something about a concept, and to express this in the form usual for such assertions, namely, to make what is asserted about the concept into the content of the grammatical predicate. Consequently, one would expect that the reference of the grammatical subject would be the concept. But the concept as such cannot play this part. In view of its predicative nature, it must first be converted into an object, or speaking more precisely, represented by an object. We designate this object by prefixing the words the concept. So what are the representing objects? Well, the answer is the extensions of concepts. So the concept F and the extension of F are co-referential. Each refers to the extension of F. So we distinguish between the concepts and the extensions, but the extensions now will be objects, and they will be objects that will represent the concepts of which they are the extension. So in Grundgesetze, concepts are represented by their value ranges, where the extension of F is the value range of F, given that F is a concept. So Frege introduces the value range function using the smooth breathing, which maps functions to their value ranges. So the value range name, smooth breathing epsilon phi epsilon, refers to the value range of the corresponding function phi, okay? And if that function is a concept, then that value range is its extension. Now, if we take this as basically the way you're going to talk about concepts, now we return to objection 2, that distinct concepts have the same extension, and Frege will simply say distinct value range names can refer to the value range qua class, now having the value range stand in as the representative of the concept. And of course, this relation will now be governed by logical law, namely Basic Law 5.
Of 5, for example, 5 would be
Any concept whatsoever.
that speaks one.
Is an actual number.
It's a natural number. Then epsilon, phi, epsilon would be
The value range of the concept is
so
an
all
actual, all the things that fall under the concept of being a natural number. Sorry, I should have put in an example.
No, no, no.
It's good. Okay, thank you. So we have a relation. We have now a relation which holds between a concept and its value range. Okay. Now, let's go back to the problem we were discussing before. Definitions are of scientific concepts. Remember, Frege is very traditional. He wants to define scientific concepts. Okay. But definitions of concepts are inexpressible in the logical language because definitions are objectual identities. Like, it's not well formed in Frege's logical language to have concept term equal concept term. It's not well formed. Okay? So the value ranges stand in for the concepts, and conceptual identities indirectly expressed by objectual identities via their value ranges. So concepts are then going to be indirectly defined by assigning names to their value ranges. So in definition, zeta assigns a name to the value range of the concept of equinumerosity. So for Frege, definition depends upon concepts being represented by objects and its value ranges that play this role. And we'll call this relationship of representational relation, the definitional relation, just to give it a name. Okay, so the point here is that this is something which Frege develops quite extensively in the first part of Grundgesetze, is that the representational relation is what he calls correspondence. So we want to be able to look at a value range term and be able to read off it in a rule-based way what the corresponding concept is. And it gives us examples how to do it. And this is critical because what the critical discussion is under scope. So define and characterize the notion of corresponding concept when you have scope relations of finding in has to be by the standard rules of basic scope assignment. And since the value range operator is also a scopal element, it applies to that as well. So the kind of fundamental notion here is between a value range and the concept which it represents, where the value range is also a class, that is the class of elements which fall under the value range, fall under the concept, excuse me. Now, if we're going to have this representational relationship between concepts and their value ranges, we should ask the question, what are the characteristics of concepts that have to be carried over into its representation in the value range? Okay, because if you can't do that, how are we going to basically establish this correspondence? And there are two things that have to be characterized. One, their characteristic marks, and two, their predicativity. So by characteristic marks, Frege just means the content of the concept. So the characteristic marks of is a natural number is being a number and being ordered in a natural sequence, for example. Those are the two characteristic marks of that concept, roughly. But the other is that they're predicative, right? All what's essential about concepts is that they can be analyzed as functions and hence to take arguments. So we have to be able to characterize both. Well, the characteristic marks are pretty obvious. It's just basically carrying over logical form. So because that the function name, the value range function combines with a concept term and it forms a name of a value range, we can see that it's carried over under composition, under standard syntactic composition. So the logical structure is always preserved, inclusive of all characteristic marks. Okay. That's kind of the easy case. Yeah. The value range extension is the value range of a concept. or a concept is a particular kind of function, a function from that maps onto as value of its value. So it's just a special name Frege gave to the value ranges of certain kinds of functions, the concept, which is another thing.
Any extension is a value range and not any value range.
An extension, yeah. So all functions have value.
Yes.
Right, but only concepts have extension. Okay, where concepts are a type of function. Or characterized and analyzed as functions, I should say. Is that
Yes.
you good? Okay, yeah. You still look a little puzzled.
Well, yeah, I think.
Digest. Okay. So let's talk about predicativity, because that's really the critical case here. So when for predicativity, what it says is phi of A expresses that A falls under the concept with the characteristic mark phi. That's how Frege cashes out semantically the notion of predicativity. But he's very, very clear that predicativity is of the essence of concepts because it has functions. So it must be an aspect of their representation, right? Because it's one of its essential characteristics, okay? But value ranges, by assumption, are objects, and so by their nature, non-predicative. So he seems to have a rub here, right? On the one hand, he has this he wants to representing objects, but objects by their nature cannot represent a fundamental aspect of concepts, that concepts are predicative. So the question is, how can predicativity of concepts be properly represented? And Frege does this by introducing a relation between objects that holds between an object and a value range, just in case the object falls under the concept corresponding to the value range. So he says, our concern is only to designate the value of the function phi for the argument delta, that is phi delta, using delta, the term delta, and value range of phi. So I do this in this way. Delta cap value range of phi, which is to be co-referential with phi delta. Okay, so the co-reference of phi delta and delta cap value range of phi expresses the equation of the notion of predicativity expressed by phi delta, and with the notion of concept, predicative concept, with the notion of membership of value ranges. So Frege then gives as his first definition. Yeah.
This is true, but it is required the proof of the one.
I'm getting there. Hold your horses.
Is this like beta reduction in lambda calculus?
Is it like beta reduction in lambda calculus? Yes.
Sorry?
I don't know.
This looks to me like the beta
Yeah.
equation of lambda.
Yeah. Oh, yeah. Yeah. Essentially, yeah. Yes. Yeah. It's essentially kind of a lambda operator. Yes. Okay. Sorry, I didn't catch your thought. Yeah. Okay. So definition alpha, the first definition Frege gives, formalizes and generalizes observations. Okay. And it's, to roughly paraphrase, it says that, so he's characterizing and defining the cap relation. The definiens, and hence the definiendum, refers to the true if and only if A falls under the concept whose value range is U. So this relation of cap holds just in case A and value range, just in case A falls under the concept of which that is the value range, okay? Now, there's two very important consequences of definition alpha. The first, which Marco went to, is theorem 1 of Grundgesetze is provable from definition alpha. And theorem 1 says it's a judgment that if A falls on f of A equal A cap value range of F, which asserts the equivalence of predicativity in membership. And 2, definition alpha is going to define class membership. Frege, in fact, calls it relationship of an object falling under the extension of the concept, okay? So value ranges, and here's, of course, the rub, value ranges are both the objects and the extensions, okay? They are an object falling under the extension of a concept, but value ranges are also extensions of concepts. So value ranges will be members of value ranges, including value ranges can be members of themselves. Nothing is precluding that.
Yeah, but problem, not for what you said, but the problem for Frege. Because the definition does not only apply in the case in which U is a value.
Right.
So the definition only defines to say particularly the notion of membership and the state.
Oh, yeah.
Is not the same.
Yeah. For sure. It's
And
membership, it's membership in the case, and it should says, it's membership in the case in which U is the value range of a concept.
But insofar as it cannot give a partial definition,
Yeah.
we define this relation also in the case in which U is not a value range.
Yes.
Is open different
Yes.
problems.
Yes.
And the only way to show that the problem is to put any object in the value range.
Yes.
It is something that you never say.
That's
and
right.
you feel it.
Everything absolutely correct. Thank you for adding that extra slide for me. Okay, but that said, there's a more immediate problem. And the immediate problem is, of course, Russell's paradox. It's because 1 and 2 together, those two things, theorem 1, and particularly the value range is going to be members of themselves, directly implies Russell's paradox. So just quickly, the derivation of Russell's paradox, as Frege himself notes, we take theorem 1, we take the following substitution instances for F, we give the concept of not being a member of itself, represented in Frege notation as I give. We take for A, the value range of F, which is that value range given. We do the substitutions and you get the next one. And if you just look at that a little carefully, it is clearly says that the value range of not being a member of that value range is a member of that value range is identical to the negation of that. So the paradox, as we know, can be traced back to basic law 5b in the left to right direction, but that is an essential ingredient for the derivation of theorem 1. So how does Frege react? And here I want to sort of roll back a little bit to the theme that I've been, wanting to have. This is all a theoretical undertaking. So he says, even now, so this is how he's reacting to this. Even now, I do not see how arithmetic can be founded scientifically, how the numbers can be apprehended as logical objects, i.e. theoretical objects, and brought under consideration if it's not at least conditionally permissible to pass from a concept to its extension, if we can't have that definitional relationship. With this, it is, of course, recognized that my introduction of value ranges in section 3 of the first volume of Grundgesetze is not always permissible. Legitimacy of our second level function, the value range function, is thereby shattered. And yet such a function is indispensable for the foundation of arithmetic in the construction he's trying to give. So the paradox shows that what fails is the logical transition from concept to its value range. As I said, the definitional relation. And to Frege, hence, the lesson of Russell's paradox that the canons of definition collapse. The ability to isolate the mathematical content with logic is lost. How can we get, as he says, how can we get the foundation if we can't apprehend logical objects? So when he comes to the notion of what are numbers, he says, Frege says, yet is it not a scandal that our science, just a sort of final remark here. So we consider the question, what are numbers? Frege says the following. Yes, is it not a scandal that our science should be so unclear about the first and foremost among its objects, and one which is apparently so simple? Small hope then that we shall be able to say what number is. Okay? And the core, what I've been trying to emphasize, that the core idea of Grundgesetze was to address this question as a fundamentally theoretical question. Okay? And where the fundamental theoretical notions are going to be semantic in a very contemporary sense. And it will concern with how reference within this, it'll be semantic in a contemporary sense with how reference to numbers can be established within the context of the theory, where reference itself is a theoretical notion. Definitions are central to the answer. Purely logical resources are sufficient. They show that purely logical resources are sufficient for the introduction of proper names for numbers. That's what he sought to show. And finally, definitions provide the conceptual foundation for scientific theory construction. And that's it. Thank you. Want me to take the end?
Thank you.
Oh, thank you.
Question. Alex.
I think it's a clarification question. In slide 27 at the top, you say that one of the things we need is that the representation. Okay, I'll tell you. I got it.
Here, this one? This slide?
No, 36.
30s,
Yeah, that one.
26,
It
okay.
says, two aspects of concept must be represented by the objects, their predicativity, and I don't see why do we need that? I mean, representations, one of the fundamental roles of representations is that they are different from what they represent, and that's why we have them, right? So that,
what they have to represent.
exactly.
But
And predicativity is the fundamental distinction between objects and concepts. So why not asking that the object that represent concept have somehow predicativity is not just asking them to not be objects.
So you mean a representation is not iconicity, so we can
Exactly.
represent
So you
without
know,
ever.
it must be, why is there predicativity of concepts so
Has
that
to be.
must be represented by the object?
Okay. I think when we're looking at anything with representation, okay, there's a point at which you say, yes, that represents something that I can reconstruct from what I'm given, what it is being represented. Okay. And sometimes we don't give enough, it fails the representation because it's insufficient information. Right? Sometimes we have superfluous information. So the question is, what information do we need in order to recover what we're trying to recover? What do we need to be able to say and say what it is the characteristics of what we're representing? Now, it's the fact that under the representation as given, predicativity is not represented. All it's represented is essentially its logical form. Okay. And then, but then Frege says, well, look, so that's fine. Okay. But we can say that what is characterized by predicativity can also be expressed and utilized as a characteristic we need in our logic by saying that there's a relationship that holds for these representations. Okay. And if it's in that relationship, then what we have is something which will basically give us what we need in term structure with respect to predicativity.
But the question is, why this last part? What do we need? I mean, because I can see that it would be good if we had that part as well. But what we need is too strong, and that is what I.
We need what we need. It's what I guess what the problem is here. It's we have to look at how Frege actually utilizes these notions in the proof structure in the nature of the definition. Okay. Because all through he takes it as a stratagem that he's able to reduce as a reduction by use of value ranges and this relation. And it's really, I mean, I'm waffling a bit on answering your question because I think to answer your question, we have to sit down and look at the proof structure. Okay, and how these notions are playing out. But the question I take it is, why does he need this notion floating around? Right? Why does he need this notion? He needs this notion because he wants to say something has a characteristic. He wants to say, oh, this object falls under that concept. But the only way he can say it falls under the concept, not by predicating it on the concept. But what he's going to do is say it falls under the concept, it falls in this relation.
But what can Kirill say that why can't he just do it by predicating? Whatever predicative thing you want to do with the concept that you cannot do with the
because this has to do with his, I believe this has to do with his reduction of the order of logic.
Oh, okay.
Yeah. Because now he's able to bring things that are going to be at a higher level down to lower levels. Yeah. Basically, what he's really trying to do is keep everything, nothing higher than second order quantification. Right. And so, and that's the only second level concept. So that's really so.
Yeah, I can see
I'm sorry, I'm not being very clear. It's really
okay. Sorry, thank you so much.
Oh, up there.
Thanks,
yes.
thanks,
Yes.
thanks by Valeria, thanks by Ed, and thanks by Robert. Okay.
And, but there's a question, I think.
There is a question? No, there is no
Oh, that's you.
question. No,
I thought it's-
no question. Only thanks.
This would be a bit of an aside, but I imagine that probably you can make some this. So let's say that Vegas logicist program actually has been carried out and succeeded. Then you could make two different kinds of conclusions. You could make a conclusion that logic contains some content and leaving out content contain mathematics. Or you can say that you could also start from another kind of view and say that logic is, I mean, from a more traditional view, it doesn't contain any content, right? It's both global, it's formal. And this shows that in fact mathematics doesn't contain any content either. Which sort of conclusion would like or what maybe we wouldn't care about the
No, you absolutely take the first.
the first okay,
Logic as content.
Yeah, logic has content. So I think I'm reading a paper about this called Logic as Science. And I think the way Frege looks upon things is that there is this kind of core pure, actually this is what the other talk is kind of about. Right, where I wrote it next. You want to sit here. He does have this core notion of pure formula. Yeah, pure general logic. Very constant. And then he builds on it. And the building on it is brought in that each one's an application in some scientific domain. And we build on that by adding axioms and wouldn't go through the So the claim, as I understand it, about Loach's claim is that arithmetic is the first science to mention it because it's a science you get by the addition of no set axioms, no additional axioms are added to the system, only definition. And so arithmetic is what you get as the first science. Then you can add geometric axioms and the geometric definitions, and you get geometry, physics, and way, and the physical laws, and what have you, and each one is an application. Now, there's a question, and I think this ties into kind of how Frege channels a very broadly continent picture about logic, is, are the objects, or the things that talked about in the logic construction, are they a different nature than others? So arguably, they're going to be API objects in a way that, biologists I think he does respect different ways to transition into empirical investigation and something like the possible in science.
Thank you very much.
Yeah, back there.
Oh, okay. Eric and
Oh, I'm sorry, Eric, go ahead.
Eric was the first one.
Sorry, I didn't see you.
Sorry, Peter.
So you make a number of moves that I found really interesting and helpful, but let me put my finger on one of them and see if I understand you right, and then I have a question about it. So at the beginning, you emphasize this point about definitions that are, in a sense, purely speculative. So at that point, even the definition of number, it's purely speculative. It introduces a sense and a reference, like fixed term sense and a reference. But if I understood you right, then once we've given the definitions and formed a theory, at the level of the theory, we can then ask, is this sort of giving us what we want? And is this, does it have arithmetic content in it? Certain symbols or definitions have arithmetic content, and they characterize mathematical concepts.
What right do we have to what he labels the definition as the definition of a cardinal number, right? Of a concept. So what right do we have to that label?
Right. Yeah. Now, this idea of arithmetic content, I'm wondering how to understand that. It's not in terms of reference, sense and reference. It's sort of, can you say a bit more about how I should think of it? I mean, at one point you said it's in terms of preserving certain marks. Capturing certain marks, number sequences, something like that. That's sort of
well, I think that yeah, that's the question.
Yeah.
Oh. I was hoping it was going to be an easy question. Look, I've always been very struck by this sort of unification idea that he puts forward in formal theories of arithmetic. And I think, I guess the view, I think Frege has a view that there's inherent mathematical content in logic. So I guess the way I think about this in a very broad sense is that, you know, the very sort of classical idea that if you truly understood reasoning, then it would be obvious and manifest that certain fundamental aspects of mathematics are reflections of pure reasoning. I think Frege is very much on this idea, where we have this articulation of logic as the theory of pure reasoning, and that he gives, and we have the articulation of mathematics in terms of the analytic maximum. So there's a notion, I think, that Frege is saying is, look, we just need to sort of have this construction of logic to be able to show, to derive the basic laws of arithmetic. But so it must be that whatever content there is, it must be in some sense just a unification. What is logic is mathematics in a sense, just a unified sense. So it's really about these kind of logical, the nature of, you know, why is the nature of function itself is the fundamental logical building block. Why is that somehow imbued with this content? And, you know, I think it's kind of mystical, you know, why this, but it's no more or less mystical than, you know, I mean, you can give it, so it starts with a sort of a theoretical notion, construction, and, you know, is that more or less mystical than taking numbers as defining?
Sorry, just a follow-up. So you think that for Frege, the extension of the value range are in many cases logical object, or only value range of some function is a logical object. So the value range of the concept of table is a logical object according to it?
Yes.
So any value range is a logical object. Yes. So if there are only value range, any object is a value range, any object is a logical object.
Yeah. Well, he discusses that, right? He discusses that possibility.
A little bit too much, no?
Yeah, well, he discusses that in the long footnote. He discusses that in the long footnote at the end of section 10 of Grundgesetze. And he says, yeah, that would be the way to go. You basically take all objects to be identical with their value ranges.
That's no. But the problem is not there.
No.
The problem is that if you suppose that any value range, because that could be a value range, is a logical object, and if only any object is a value range, so any object is a logical object. So this table is a logical object.
No, the value range of being that table is a logical object.
But then it's not true that any object is a value
That's
range.
not, right?
So it is not true.
Well, that's presupposing that
And
table,
so
but you're presupposing that the table is actually an object.
Sorry?
You're presupposing the table is an object.
Okay, so either there are no objects that are not logical objects. If the table is not an object, and this table is not a value range,
I think
it
that,
means that
I think
this
that,
table,
look, I think that I don't want to go down this road so far, because if we're looking in the domain of logic,
yeah,
we have to ask, what are the objects? Look, he's constructing, you know, so to speak, kind of proto-model theory. And yet, you know, with the conceptual hierarchy, one has to ask, what are the appropriate objects that he's dealing with? And those objects within this theoretical construction are all and only value ranges.
okay, so we have to suppose that the domain that we are speaking about is not the total domain, but we have the
That's right.
domain of logical object. And
That's
this
right.
means this is the.
It's not a total, I don't think he is, when domain, with respect to logic as a science, with respect to logic as a.
And we should be able to distinguish between the object of logical object and the object that are not logical object before going to object.
Okay, so
We needed to have a concept of logical object before giving pure concept. So my interpretation is for him there is only one total domain, and in total domain include any object. So the question is that any object is a value range, means that they can understand any object as a value range, but then we have to deny the fact that value range are by definition a logical object. Some value range are logical objects, other value range are not logical objects.
okay,
This is what the way which I see it.
okay,
This is not the same way that you.
no, it's not.
Okay.
Listen,
I didn't know that Frege
Just the retrospective essay with 1914 is turned out that theory becomes about 8. Would you again consider using that as a way of interpreting this?
As far as we can discern from anything that we know, Frege did not read Zenoa. He seems to have been completely ignorant of all the developments that were occurring in sexuality between Russell's paradox and the Vedic. Almost all of his work in the post-paradox period are simply reflections and thoughts about his own thoughts and what he thought he accomplished. It's very insular. There's no recognition that he engaged, outside of a correspondence with Hilbert, which led to the foundations of geometry papers. There is no evidence that he was really keeping up in any way with the topics.
But there is much more than that. This is what happened after the paradox. But apparently the paradox presents a very strange situation. Because of course, if you know the Cantor theorem, you should immediately understand that the article 5 is contradictory. Because article 5 supposes that there are more, that is the same number of objects than concepts.
Yeah.
But of course that is not possible when on an infinite
Right.
domain. So Cantor theorem immediately contradicts article 5. So that did the Frege know Cantor theorem? Apparently, either he did not know, which is quite strange, because this was proved 20 years before, or he did not understand. Or I don't know.
Didn't he write about that? Didn't you write about it? Who wrote about it? Somebody has a recent. Somebody wrote about that.
I think that Gabriel is piano.
I read a paper recently about why didn't Frege know about Cantor theorem?
Yes, I read it. So I think that the general the question is he did not understand it.
Yeah.
Okay, I have a point that possibly is an objection, and
I think that you should respect this objection because I made also this objection, sorry, in the preprint of this talk, and I see that you present the same idea here, so you should be ready to my objection. So I can present objection if you want in this way. Okay. No, here. Okay. You say, if I understand well, that there is a problem with definition because definition are identity, but identity cannot be identity between a concept. And at the same time, a concept are what is to be defined, at least not always, but not any definition is to be a definition of concept, but we need definition of concept in a crucial way. So what's the problem? How to solve the problem, and the problem, your solution of the problem is that what we define are not a real concept, but a concept via their representation. Their representation are given by your interest. So if this were the case in this way, Russell paradox, it would be absolutely destructive of Frege, not only of the definition of number, but also of its theory of the very basic idea that it encountered. Now we know today that the basic project of Frege can be in some sense represented and vindicated not only by the strange operation that consists in taking the principle as an axiom to eliminate tensions, but also in at least two other ways. One is the one that consists in extracting the comprehension. And so not to be strong enough to give arithmetic, but still to make the system completely safe. But if the problem was so complicated, was so strong, this would not be enough to say the idea. But on the other side, Fernando Ferreira proved that you can also much better than that
You can maintain basic law 5, you can maintain full comprehension, and you can still say for certain prediction by distinguishing between predicative and non-predicative constitution. Okay. So apparently, we know today that the Russell paradox is not so destructive of Frege project. We can go out from Frege project. But in your interpretation, it seems that it would be strange to do that because this would destroy the very basic idea of our definition could be done. Now, my point is that I do not agree with you on the fact that to solve the problem, the way to solve the problem is to say that Frege definition of concept is the definition of value ranges of practice. And because, why I say that? Because this does not fit with the way in which he gave definition. When he gave a definition of concept, what he gave is something like that. He defined the concept. No, let's take it's a formulation. Take he defined the concept. You to be something. Okay, so now U is a Latin letter, and the Latin letter in his language, if we understand, if you forget that is, you think of the definition, you take the same judgment, and you have here something as a sentence with a Latin letter. This sentence without that does not make any sense. But when you put that, this means that any substitution of a Latin letter with a Greek letter give a name of the two. Okay, so this means that defining that, so given this definition, simply does define the concept not by defining the value range, but defining all the values of the concept. So give a schematic definition. So the way in which
I call generic, I call that a generic definition.
The schematic definition.
Generic.
So the way in which a concept is defined usually is not by defining the value range of the concept. The way in which a concept is defined usually is by defining in only one way, schematically speaking, all of the value of the concept, which is perfectly compatible with the basic idea of the language of the Grundgesetze, that is a language where concepts do not appear. They only what appear are simply the values of the concept and not the concept. What is seems to me also perfectly compatible with the basic metaphysical idea that concepts do not exist. What exists are simply value of the concept, and concepts manifest themselves as the form of the way in which the object and the only thing that exists present themselves. So why do we need to pass by this intermediary of the representation to define a concept, when in fact we define a concept by directly defining concept, that is by defining values of concept and not value ranges of concept.
Over much of what you said, I do not disagree. And I went out of my way to point out that definitions can be either generic or specific. In the case you're discussing is a generic definition. He gives specific definitions. So, for example, of 0 and 1 are specific definitions which introduce proper names directly into the language. Now, in this case, what you said, the way you described it is exactly correct, right? This is essentially, this term is to be understood universally. The overall definition is going to be a universal statement. And we'll be planning it out with respect to each of the cases of substitution instances. So what's the term that is introduced into the language by the definition is this term, and only that term. That's the novel term. This is already in the language. It's not being introduced.
You mean that they have not in logical sense?
This term here, this symbol is being introduced as a term. It's a function name. A function name is what's being introduced into the language is a function name. So a generic definition is form will be introducing function names. Okay, and function name will be characterized as referring to a function, which gives for any argument U the value specified by the definitions. That's a value range. What's on the right-hand side, which you left out, is a value range term. So what basically he's saying is that the function here is going to be a function. This is going to refer to, for any given value, it's going to refer to, for any given argument u, it's going to refer to its value, which is going to be that value.
Not necessary. This happens when the concept is the concept of being the value range of something, as the case of the concept of number. That is not the case, for example, when I have to define the horizontal or
The horizontal is not
or
defined.
this,
The horizontal is not defined.
okay, not definable
Horizontal is
horizontal.
not
When
defined.
you define this concept here, this relation, what you define is not a value range. What you define is an object. Because you define
Yeah.
it is
No,
by
it is a value range.
function.
No, that's incorrect. It is a
It's
value range.
not a-
What if
necessarily a value
it's
range.
defining is that it refers to the true, and the true is a value range. Of course, it's a value range.
The true is a value range under a convention.
It's still a
Mm,
value range.
That's the true is a value range under
And the convention or not, I've written
And they
about
say
that.
that you can
I've
make
written
this
about that,
convention,
but it is a value range.
made, so in this way.
Well, that's why it works. That's
It's,
the reason he makes it a value range.
Your point is that any time that I define a concept, I define a value range, because to define a concept means to define the true or the false, because the value, when I define a concept, I define a value, and the value of a concept is the true or the false, and insofar the true and the false a value range, defining the value of a concept is defining the value range, and so. Okay, that is a way to go out, but the immediate way in which I would understand your interpretation is that if I want to define this thing here, what I should define is here, what is not true. Define this without defining this.
Wait, hang on. What's being defined here? Am I define? I mean, what is being defined? What you're leaving out is the definiens, right? What I'm expressing here is a definition which is giving the definiens. Remember, this is just a term that's going to stand in for the definiens. What am I defining? And here, the definiens invariably. I mean, we can talk through all the individual definitions, but invariably, this is a value range term, which is a definiens. And with respect to this definition, he's going to assign basically a name for that value range. In this case, for each instance of this.
But it does not define necessarily this value range there.
It's value, well, it
So
depends
this
on
value
whatever
range-
it is. It's whatever it is. If that's this value range
What I define here
is,
the truth. No, because this is this concept here is defined is a true value, and so this is the true or the false.
yeah,
And the true and the false is not necessarily a concept for which this is not the true, this is not the false.
it depends. If we're introducing, if this term is going to be a function which is a concept name.
Yeah.
Right?
The
And
value
this-
range
and this
of a
is gonna be-
concept.
This is going to refer to the true or the false.
Yes, this, yes, but not this.
Yeah, I agree.
No, not this.
Yeah, but this will be to a value, whatever this object is. It'll be to an object with true and false or object.
If I take
Marco, I think we're losing the audience here. So I think that we will continue afterwards. Are there any? I'm sorry. You hear Marco every week, so this is not a. Other questions? Yes.
The question relates to what Peter also asked about. So
Yeah.
Russell and Wittgenstein and others famously were very inspired by Frege and really next to develop the thinking together. But still they didn't communicate with them a lot because it was so insular afterwards or like after Russell.
Russell and Frege have an extended correspondence. He also has extended correspondence with Wittgenstein visiting him. Both of these, I mean, they've all been published. In the correspondence is the correspondence with Russell and with Wittgenstein, it's a book. We only have Wittgenstein's side of it. We don't have the Frege side, but not Wittgenstein's side. because it was found, it was like in the basement of the Vienna City Hall, they found this box, which had, from Wittgenstein had Frege's. Frege clearly didn't get much past about the first 2 pages of the Tractatus, as far as one can tell, what he had to say, but maybe that he shares that with other people. No, and look, Frege was not isolated. He felt, and he participated in all the intellectual discussions of the day. He felt he was responding to the intellectual trends of what was going on. And Jamie Tackenden and others have done a great service of trying to sort of show us the kind of intellectual milieu in which Frege existed, the kinds of ideas that were going around. I mean, it was a much more, it was a provincial university, and so there were lots of internal societies, and soirees, and senior professors would have weekly meetings at their homes where articles and things were discussed. Things were passed around with few copies of things. So he was very much part of the intellectual community. He certainly becomes much more curmudgeonly after the paradox. There's no question about that. But the major function and concept, which is the major advertisement that he gives for Grundgesetze, was given to a learned society, local learned society in Vienna. Funny story. Apparently they had the records. So I was told they had the records of everybody's attendance, and if you were a member of the society, you didn't pay for things. You sent the bill at the end of the month to pay for whatever they just put the record. And apparently, Frege never even had one beer. Never once. All things he basically went to beer at all. Everybody's sloshing down beer. He apparently never drank. So, whatever.
Like what was then with Cantor and Frege? What do you know about Cantor?
Well, they had a correspondence, didn't they? They not an extensive correspondence, but the main problem was that even if Frege did not understand Cantor's theorem, Cantor did not understand Frege's account of number. And so he writes, there's a critique he gives. He completely screwed up. He didn't understand those equivalence classes. Cantor did not understand Frege's definition. And Frege writes an article to correct Cantor about this. It's interesting.
Yeah, that's interesting.
Yeah.
I have a question that might be like Eric. So you might have really already answered it.
Okay.
But just the term manifest, or you quoted Frege saying arithmetic is manifest in logic. So the milieu of logic, you can't really say it's manifest. You have to actually go through the definitions. Right, so the definitions of means to make something manifest. Manifest seems like it's something passive.
Yeah. Well, I think at some point, I don't remember the exact quote, maybe you guys do. He says, you have to look at this as it's like from small acorns, giant oaks grow. And in some sense, the oak is already in there, in the acorn. Okay. I think that's the sense Frege has. Right? Yes, you're absolutely right. You have to show it. You can't just say it. You got to show it. And the showing it is undertaking the proofs in a system constructed in the proper way, just to give,
having the genius to come up with these definitions, right? There's the definitions themselves you can't read off from the budget.
Right.
And
it's very interesting. Frege is quite clear, right from when he writes the Griffith, that he's got this project in mind, and he thinks he can pull it off. And he's really putting it out in a very systematic kind of way. Okay? And in the quote I gave, I had this project in mind since the Griffith, and I gave the fundamental concept in Vermont, and now I'm going to do it. Okay. It's very, very hard to imagine that he could have really had a deep understanding what the proofs were going to look like at the time of the Griffith. It's just very hard to imagine. So how does that emerge? There's a famous comment someplace that he makes that apparently there was a whole first written out copy, at least volume 1 of Grundgesetze, which he then destroyed, or we don't know how, and he rewrote it. And one speculates, well, what was the insight he had that led him from one to others? And most people think it was really understanding his role of value ranges. It was really the insight that he had. So, it's very interesting sort of how he really, the proofs are very, very interesting, very interesting. And because his canon of proof is, as literal as it can be, it's literally line by line by line, and everyone has to be annotated. Its justification in terms of the rules of inference has to be annotated each time, right? So every step is completely laid out. And of course, there are standard maneuvers he makes, right? So the way he introduces existential quantification, the standard maneuvers he makes to do that, are very interesting. But it's a very, it's a lot of work. And you can imagine, going back to what Marco was saying about finding out these other ways he could really try to capture some way one might say is the essence of what he wanted. You can imagine that after going through all of this over a 10-year period, and then finding the paradox, the psychological energy that would have been needed to go back and redo it in some other way to avoid it. And he didn't make an attempt to avoid the paradox. And it's very interesting. Roy Cook has a very interesting recent article about Frege's way out, the maneuver he made. Very interesting article. But would he want to go back and do that? That would be pretty crushing. Pretty crushing.
There is more than that. The point is that the only way that we could solve in some sense the problem is would have been by controlling the French. And the point is that Frege did not understand French.
No, we needed Russell. We needed Russell for that.
We needed Russell.
We needed Russell for that.
They did not have in him
Yeah.
to solve the problem because he did not grasp the notion of comprehension.
Right.
For him, any formula is
Well, he kind of, that's not entirely true. Because what he actually does in the way out is that he actually does suggest a restriction on comprehension.
yes.
I mean, that it is not as articulated as as it becomes later with Russell, but he does see that as the way out, and he adds that he conditionalizes basic law 5, and hence theorem 1, by basically limiting comprehension.
Yes, if you want, but it does that on a logical basis and does not take out the general problem of what is comprehension.
Oh yeah, sure.
There is no notion.
No, he's not. No, he's just saying it's a fact.
application by the fighter not wrong, so eliminate this case.
It's definitely a patch. He just thinks he can patch it up by basically eliminating, stipulating away the bad case. Yeah. Eric.
I have another question. So I found it really interesting how you make the how value ranges represent concepts or extensions represent concepts central. So is this the overall picture? Earlier, so in his earlier writings in Grundlagen der Alten, there's this puzzling footnote that we quote. It says we could replace extension with concept. So is the idea at that point he didn't really distinguish between concepts and extensions as
With purely extension. It's purely extension.
yeah, and then he starts to make a sharper distinction between concepts and objects and definite extensions. And then he starts to think about how the extension can represent the concepts, and that leads to the whole discussion in basic law. Is that the
Yeah, that's the line. Yeah.
and in a way that also leads into the paragraph.
Right.
Right. Yeah, no, that's I
That's
haven't
fine.
seen that so very good progress.
Thank you. You had it? I think you had something.
Yes,
And then,
for me to understand this, when he says that arithmetic and logic are not to be distinguished, I can see how the project of reducing the arithmetic to logic can be it's a reasonable project, but what about the other way around?
what do you?
Well, reducing logic to arithmetic if they are not to be distinguished.
Yeah, I mean, yeah.
They are different. Arithmetic is a part of it.
The point is that arithmetic is a particular science, logic is a general science. So arithmetic is not a generator of logic. So within logic, you can make arithmetic. You cannot make logic. Yeah.
So there is a distinction.
There is a distinction in the sense that
So-
one includes the other and not the rest.
So the way I like to look at it metaphorically is, here's logic. I pick up my math classes. I look at logic now with my math classes. What I see is arithmetic. And somehow that is there. And the point of the definitions is to reveal that structure. So
I can see that river is water and the pond in the river is the same. The pond is not.
yeah,
So probably some basic questions again, but it's almost the two things. First of all, what was the scope of that? So one thing was the arithmetic, like how much mathematics would we actually show that can be reduced to like all of mathematics?
Not geometry.
it gets, when it gets to the real numbers, it gets very hairy. And you know, he's partially through studying the real when the paradox comes. And he never goes on. There's supposed to be a third volume of Grundgesetze. So we really don't, and we don't really have much idea of what it's like. Marco has some very interesting things to say in that realm, much more than me. So he's the one to talk about further mathematics.
Certainly,
But,
that's
sorry,
not.
But the prime parts of part 1 and part 2 are really concerned with living with the natural number. That's really the main concern there. It's only when it gets past that to part 3 that it makes sense. Yeah, sorry.
Yes, certainly he does not want to reduce geometry to logic.
No.
That is quite clear. Geometry is
No.
because we already come to geometry.
Right.
So Kant is only wrong in everything that is right in geometry. So geometry is requiring a spatial intuition necessarily. This is absolutely clear on that not only in the last part of his slide, but also in the Lagen.
Would that also be intuition of
In the Lagen is perfectly true. And then the problem with real number is much more complicated because when I try to define a real number, so why try? I say try because the idea was to define a real number in the second, the third volume in the second. And in the second volume is present part of the definition, but not the totality of the definition. But when the second volume is on the point to be published, you receive the letter by Russell. And so it never writes the third volume. So we can imagine the way in which is to have defined the real number, but we do not have the complete definition, we only have a partial definition. Now, what we should to be clear from the partial definition is that the definition of real number, the definition of domain of magnitude, because for take a real number of ratio and magnitude, so the part that it is given the second volume and the second to define the domain of magnitude. And the definition of the domain of magnitude does not require any new action. It's essentially a definition within the system in which you define a natural number. So it works as a definition of natural number. You take the system and then you introduce only this definition, and then you have what you need. But what appears to be clear is that in order to pass the domain of magnitude to real number, you need to define a ratio on magnitude, and the definition of ratio magnitude requires new action. This is not what is right, because it still did not do, but it's simply impossible to imagine, not only to me, but in general, to anyone or the interpreter of this matter, that he could have done it without a new action. And now to say that this new action, the new abstraction principle is a logical action, much harder than to say the basic law 5 is a logical action.
So
this seems to be a specific action that just concerns magnitude. And so even the fact that you would have a standard notion of logicism, admitted that there is a logic for arithmetic, what I do not believe. But it's another story. I do not want to explain to you my idiosyncratic interpretation of it. So certainly the extension to real numbers is very complicated. So
there's a paper written called Logicist, and you know, I think he argues that Frege has a very strong notion of application of logic.
Sorry?
Application of logic. And so the idea is that you have the courses, the basic, and that's embedded in all scientific inquiry. Then how do you get special, how do you get applications? You add axioms and appropriate definitions. So in this regard, arithmetic comes out as I said the first science because there's only class. And moreover, they're logical. So then the question becomes, what happens when you add additional axes? Well, geometry is going to be non-logical axes. So it's not reducible. But you have new axes, you have a different size.
What about the Hilbert-Gaussian sort of organization of geometry? That could not be thought of.
That's a long story. That's a long story.
It's a series of
Hilbert.
Hilbert's axes.
So Frege has a correspondence with Hilbert.
Yeah.
And this is very much the topic of it. Older Antonelli and I wrote a paper on this called Frege science. And Frege really feels he has this very fundamental foundational disagreement with Hilbert about the nature of axioms and the nature of definitions. Okay. And he really lays this out. And he's very enamored of this discussion with Hilbert. And he suggests to Hilbert that they should publish their correspondence. And Hilbert just totally ghosts him on this. He just totally ghosts him. He just basically says, no, but it's an interesting topic. It's a very interesting correspondence. And it's you know, the way you see Frege kind of, it's just an emergence of these sort of model theory notions, what emerging. Now Frege is responding to Hilbert with respect to these notions. And for Frege, every language is fully interpreted. Every language has no variation in interpretation. No notion of non-logical constant, none of the notions you're familiar with. For Frege. But you can for Frege look at this language and another language and compare the language. So you can get a metalogic, is what Antonelli said. But it's a very different kind of notion to get these kinds of results. But it's very interesting correspondence and it's really interesting. So I recommend it to you.
There is a work by Pitzer College.
Yeah, that and as a paper by Antonelli.
So the fact is, Frege did not understand Kant. Kant did not understand Frege. Frege did not understand Hilbert. Hilbert did not understand Frege. Frege did not understand German.
Yeah. Well, you know,
Okay.
it's the way people are. It's the way people are.
So what is our hope for this?
Yeah.
Early in the presentation, I thought I understood you to say that one of the criteria for definitions is that they don't introduce any content. They're eliminable in the sense that they perhaps they make things more economical or clearer. But in the rest of you didn't say quite as clearly, but I just get the impression from the rest of your presentation there is something essential about definitions to what Frege is doing. And neither you nor Frege, I think, would walk into the contradiction. Definitions are indispensable and they are dispensable. So I'm trying to understand in what sense are they dispensable and what sense are they indispensable?
All definitions are dispensable. So every proposition can be proven with a definition can be proven without the definition. So there's no thought that is expressible in virtue of a definition that was inexpressible otherwise. However, some definitions are ones which are just, every definition is there. Some are just there because you're just using this over and over and over again. Okay, you just need to capture a notion that you're going to need to use. Okay. And so you do that, whether those notions are something purely logical. So for example, take the definition of the converse of a relation, which Frege gives a definition for, and it uses the symbol, the converse of a relation. Does this capture this definition something really a fundamental concept about logic? I don't know. But given the project and you're adding definitions in the context of a science, there are some definitions that are going to be significant as capturing the concept of which the science is about. And that's the significance of the definition of cardinal number of a concept. Okay. It's eliminable, right? But it wouldn't, not eliminating it helps, gives you tighter, shorter proofs, or the proofs are quite long anyway. But what it does is as he says, it brings to our attention notions that are the core notions of the inquiry. So in that sense, they're not technically in any formal sense eliminable. But if you eliminate them, well, what are you doing in terms of the science?
So in a sense,
So that's
you can
like a
eliminate the
psychological-
definition.
Yeah, there was a quote I had.
Yeah.
There's a quote I had where he said, it was about Hume's principle. So that was the stuff I skipped about Hume's principle, actually. Let me get back there. So, Hume's principle is given in Grundlagen as a recognition condition. It has a cognitive significance. It's a condition which says, this is what equinumerous concepts have in common. It's supposed to allow you to recognize when you have a number. And so he really introduces this as kind of having a cognitive role to play. Okay. And he rejects it because it really can't play the role it needs to play. But he still believes that definitions are somehow to allow you to recognize fundamental concepts. And that's what you're giving them for in the context of what your theory is about. They characterize what your theory is about. So Hume's principle is, he entertains it as a definition because it will satisfy this cognitive criteria. But he rejects it because it's linguistically dependent, dependent on the way that these particular things you're introducing are represented. Whereas what definition should be doing is giving you the term that's doing the representation. So he rejects it, but he maintains the intuition. The intuition, I don't know if where I have the quote. I don't think I have the quote here. Yeah, this one. Make something prominent by demarcation and then designates it with a name. So the first part is the cognitive role, recognition. The latter is the logical role. So yeah, exactly right.
So you can eliminate the definition, but you cannot eliminate the concept of the definition.
Right. The content.
You cannot make clear that we are focusing on this concept, but still you need to use this concept in order to do what you want.
Right.
But according to you, basic profile define the value range function or not?
Now your range function is undefined.
And the basic functions are not defined in the sense that they are not defined, for example, horizontal. You said before horizontal is not defined. So in a sense, it's clear that it's not defined, it is not defined in the system. But do you have a much larger idea that not defined or they're not defined in the system?
They're absolutely indefinable.
Yes.
I don't know how they're absolutely indefinable.
We are not defining in the system. But they are
They're what he says, we all know. In constructive theory, you got to give me something to start with.
Yeah, okay.
You got to give me some primitives.
Okay.
Right? And
Otherwise, it's
yeah, you can ask if I construct a good theory and based on certain primitives, it's perfectly fair to ask about the nature of those primitives and why they support the foundation of the theory. And can you get a deeper analysis of them? That's all fair game. But you got to give me something to build my theory on. Okay. And what you'd like Frege asks is to be given is the fundamental notion of function and these fundamental logical functions. And then the proof of referentiality is intended to show that all of the 8 primitive functions that he gives are all referential.
Okay, this is clear. But now the question is the following: do you think that the, so to say, non-formal definition of the horizontal or the negation of what you want is on the pair of a non-formal definition of the value range function, or the value range function is defined in some different way than to be correct?
That introduction to value range function from the same order as the introduction.
So according to you, it's exactly the same.
Introduced in the same way. And each of the things, the 6 basic laws all correspond to one of the basic functions, basic logical functions. First one's conditional. 2 is 2 forms of generalization. 3 is identity.
When you define
4
the
is
horizontal, you say, I define the value that the horizontal as for any argument, as for any object as argument. It's the same for negation, the same for implication, and the same for all of them, but not for value range. For value range,
it's not in the list of definitions.
Sorry?
It's not in the list of definitions that he gives in Grundgesetze.
Exactly.
Those are the definitions.
Other questions?
I can keep on going, but I'm not sure.
Go, the last one, go.
Okay, the last one. So you said that that Frege agreed with Kant on that the geometry was synthetic a priori. But now Kant didn't know about non-Euclidean geometry, but Frege did, right? Presumably. And he also, even in the later years, he also knew that about relativity theory, that actually our best theory of the universe was based on non-Euclidean geometry. Does he ever discuss this in terms of why? Then it becomes difficult perhaps to keep on saying that actually if we examine our intuition of space, then what we get is Euclidean geometry. What does he ever discuss this sort of tension?
Yeah, he does. He has a discussion in Grundgesetze of non-standard geometry. And what he says is very strange. He says we can form thoughts, what he calls a judgeable content, about these things, and we can look at them, but they're not judgments. The only ones that are true judgments actually truths are the Euclidean axioms. And so it's very weird.
So it's very constant.
Yeah, it's very constant. Yeah, it's very constant. Yeah, yeah, exactly. It's very constant.
Can you repeat what you're saying?
If I recall correctly, maybe Erica, you recall these passages better. There are passages, I think around section 20 something, if I recall correctly. He remarks about non-Euclidean geometry. And my recollection of what he says is, these are not judgments. You can form these propositions, you can reason about them, but it's not judgments. You're not dealing with judgments. But if you want to deal with judgments, you're dealing with judgments, then you're dealing with
Strangely enough, there is an answer to this question that is not given by Frege, that is given by Russell in his book, the first important book by Russell, which is the Essay on the Foundation of Geometry, in which he defends the Kant by arguing that, of course, Kant is wrong in saying that the only possible geometry is Euclidean geometry, but it's not wrong to say that there is something that is necessary, which is essentially projective geometry. So the error of Kant was not to have seen that metric is something that is in some sense conventional, but the projectivity that contained by claim the three possible geometries is completely Kantian. So Russell the Kantian conception of geometry with the basic distinction, the difference that where Kant sees the necessity that is in Euclidean geometry, no, the necessity is not in Euclidean geometry, the necessity is in projective geometry, and then you give a different notion of distance, and then you have the three different methods of geometry that you can give, and this, of course, is not a priori, but the projective geometry is a priori. And this is an answer that Frege could have done, but it do not give, but Russell is completely clear on that.
Okay, so it's time to start the next talk. I started my talk now.
I think that let's go.
Thank you very much for doing all this. Thanks, you're a great audience. Yeah. I need to recover.
Can you copy your advisor?
Oh, okay.
And I hope will you be in Davis when I give the talk, and so we can talk some more. So sorry that we've done not minutes today, but we had a little bit of a chance.
Good, good. Great to see you too.